Going to be working on percent change, which is going to take the information that we already have been covering with percents and then adding a second step onto it. So most percent changes problems are going to be 2 or more steps. And it's really important to remember as we're working through these problems that, like most math problems, there are going to be many, many different types of solutions. So there is not going to be just one way. So let's look at our first problem. And one of the nice things about percent change is that basically every problem that involves percent change has to be real world automatically, which is really nice. So I was shopping online and I noticed that there was a 70% off fall sale for Vikings gear, which I think was really exciting. And since I don't have enough Vikings gear, I wanted to buy some. Well, they didn't tell me what the new price would be of this really sweet Dalvin Cook jersey. So the jersey is normally $35 and it's 70% off its normal price. Well, there are two ways to solve this problem. The first one is you got to find 70% of your original number, which is exactly what we used to do with these problems. So, multiple ways to find 70%, but I'm going to try the decimal algorithm of multiplication. So I get 0, 0. I'm done with this digit. And then I get 35 and 24. So my answer ends up being $24.50. It's going to take 70% off my original price. And when I do that, I end up having a new price of $10.50. So to recap, to find 70% off, the first thing I did is I found 70% and then I subtracted 70% from the original number to get my new price of $10.50. Now there is another way to find 70% off of a number. And I would say this one's a little bit faster, but a little bit harder to understand. So you got to stick with me for a second here. If we originally look at a number, 100%, that is our regular price. That's what we started at. And if we want to find 70% off of 100%, that means we have 30% left. So if we think about our original problem where we're doing 70% off the original price, that means we are paying 30% of the original price. So then if we do $35 times 30%, we should end up getting that $10.50 again. So let's see if that works. And it looks like we did get $10.50 again. So two ways to solve it. You can find 70% and subtract, or you can find what percent is left and then multiply for that number. So I have two items here that are both on sale, and I'm going to do each of the algorithms. So on the left side, we're going to do the two-step algorithm, which means I'm going to find 25% and subtract. So I'm going to take 25% of my $14, and then I'm going to subtract that from what I started with. So I end up getting, whoops, that should be a 5, $3.50 off the normal price. So now I'm going to subtract $3.50 from what I started with. And I end up getting $10.50 for the mug on the left. So let's see if the mug on the right is cheaper. Now I wanted to do a different strategy here. So instead of finding 40% and subtracting, which would work, I once again want to think of what percent do I have left over. So if I start with 100% and I'm taking away 40%, that means I have 60% left, or I'm paying 60% of the normal price. So if I do 60% of this, I should be done. So if I do 18, times 60, let's make that a 2 right there, and we're multiplying. Let's see what we get. So 48. It looks like it is going to be a tiny bit more expensive. Therefore, the mug on the left is correct. Now remember, these two algorithms give you the same answer, so both are equally correct. You got to figure out the one that is best for you. So what if we already know, or what if we want to find the sale percent? We're given the sale and we want to know what percent sale that is. So this helmet is normally $45, but it's currently on sale for $25. What percent sale is this? And now I'm going to write something down that I need you to write at the top of your paper. And if you bring it to me, you can get a piece of candy. And this you're going to hear me say 100 times. Change over original. We find how much the item changed. We divide it by the original number, and that is our percent change. So for this problem, the helmet is normally $45, so that is the original price. Then we find how much did it change from here to here, and that is a $20 decrease. We divide that by our original of $45, and we turn that into a percent from there, which we've done a lot of in this unit. So you could do 20 divided by 45 right away, but personally, I'm going to make this into a simpler fraction by dividing both numbers by 5 before we start. So then I get 4/9 as my fraction, and now I'm going to do 4 divided by 9 to get my percentage. Okay, so that should be 4 groups of 9 is 36. 4 groups of 9 again is 36, which means we're repeating from here. So it's going to be about 44 4/10% sale. So, big thing to remember, change divided by original to find the percent change. So let's do 2 examples on percent change, remembering once again that it's change divided by original for each problem. So for this problem, the original is $20, and the change from here to here is $4. So we have 4 divided by 20, which equals 2/10, and 2/10 is equal to 20%. Okay, so that one wasn't too bad if you understand the change over original. This one on the right is going to be a little bit tougher, but the same idea. Once again, from 80 to 50, we are decreasing by $30, and the original price was $80. So I end up getting 3/8. Well, that's not one of those benchmark fractions, so we have to do long division. So I'll do 3 divided by 8. This will be 3 groups, so 24. This will be 7 groups, so 56, as my friend 50 Cent would say. And then, oh, this one's going to work out nice. It ends up being 5 right on the nose. So 375 thousandths is the percent, 37.5%. And that is percent change. Not an easy concept, but really real-world applicable in many, many situations. As always, if you have any questions, make sure you let me know.